Number one, and yeah, the first few are matrices. You can solve this however you want. If you want to make a matrix, you can do it. But I think it's easier, and probably you would agree, if you solve it like you did in 8th grade. So I'm going to take this row and times it by 3. And then add them together. So like that would be negative 3x minus 9y equals 15. And 3x minus 4y equals 1. Add those together, and the x's cancel, and you get negative 13y equals 16. Oh, that's terrible. Did I make a mistake?
That's what I got.
Oh, that's horrible. So y equals 16 over 13 negative. And you can plug that into either one of these equations. It doesn't matter which one. Both of them are awful. So which one? Pick your poison. Let's do the first one because it's just one. So it's 3x minus 4 negative 16 over 13. This is copied right from the CBE practice. 14 over 1, that is 54, is that right? 52? 6 times 4 is... I think it's 54. 3x minus 54 over 13. Is that right? Feels right, but I mean, it's awful. Is it 64? 64? Oh yeah, 20. Okay, 64, yeah.
Wouldn't it be plus 64?
Yeah, plus. Thanks, Chris. So I minus 64 over 13 from both sides. And 3x equals 13 over 13 minus 64 over 13. And that will be 3x equals negative 51. What's up? Jackson. It says now. That's 1. So then I divide by 3. So I times that by 1/3. And I get x equals negative 51 over 69. 39. 39. So the answer is horrible. And did I 13 times 3?
Oh, okay. Can you not like just divide 51 divided by 3?
Oh, does it reduce? Yeah, you could. Is it 17?
Yeah.
So this would reduce 17, 13. Yeah. Feels the same. It's the same thing. Negative what? Did I make... So, like I said, that is straight from the CVE, and it is not pretty. Don't expect pretty. Sometimes it will be, and sometimes it won't be. You guys, do I have to do that again?
No,
I can.
no, it's good.
Let's do another problem.
This is being recorded, you'll upload this to YouTube.
It will be on my YouTube channel, but do you want two versions on the YouTube channel?
Give us a really easy one that like.
I just copied these from the CVE. I don't know easy or not.
Yeah, I'm okay with this one, but it's not good.
It's just, it is awful, and it's just, I think the hardest part is you don't have calculators to math frac for you. You have to actually do the fractions and the work with the fractions. Yeah, you have to do 5th grade math again. Do you want me to? I will. I'd be happy to do another problem. Okay.
Yeah.
Josie said no. You're out of luck. Okay, this is number 2 and number 3. I put 3 versions of this. If we have RREF, this is RREF. It gives you both versions. It gives you the actual non-reduced, like with all the numbers, and then it reduces it for you for number 2 and 3 every time. Okay? RREF, and this is important. You have the diagonal, and all of these are zeros. Okay? And then
Is it always gonna be like that?
it will give you the unreduced and then reduce it for you. So you don't have to do the row manipulation like we practiced. But you're going to look mostly at this 3rd row. Okay? It's consistent because I have ones on the diagonal. And when you have the ones on the diagonal, it is consistent. Consistent. And independent. It's consistent and independent, and it is x equals 10, y equals negative 11, and z equals 12. Any questions about that?
That's the answer?
That is the answer.
That is so easy.
It'll say x equals y equals, and if you want, I can pull up the CBE. It'll take a minute.
I trust you.
But I mean, I don't mean that. I mean, it's gonna be. Don't make me log in again. It would be useful for you to see what this looks like. It makes me do all of this. So you can see what it looks like on the final. It looks like this. So it reduced it for you. This is the same. This is number 2. It reduced it for you, and it has down here like 7 pages of how to fill it out. But what you need to look at down here is at the bottom, it says if it is independent, which is the one that we had, has x equals y equals z equals. And then if the system is dependent, then it has also x equals y equals and z equals. And then if the system is inconsistent, you type yes. So you need to figure out which one it is, and all of the boxes that don't apply need to be nah. So let's go back to the notes. This one is consistent independent because it has the diagonals are all ones. So you have x equals y equals z equals. Does anybody have questions about that?
That makes it consistent.
Yeah, it is consistent. This one is also consistent.
Not independent.
It's dependent.
and dependent.
How is that one
That's just
consistent?
because the zero is.
Because the zero doesn't count.
Because you'll see what inconsistent looks like in a second. This one, it would be x plus 2z equals 1. Y plus z equals negative 2. And z equals z. Z is the free variable, so you set it equal to itself. Z equals z. Because 0 equals 0. That's what makes it consistent. So to write this in, you have to write it in terms of z. So you would minus 2z from both sides. So x equals 1 minus 2z. And you would minus z from both sides. So y equals negative 2 minus z. 2's and z's, man, that's hard to write. And then z equals z. That's what you would write in the box under consistent dependent. So it would be the second row. This one down here, this one is inconsistent.
There's a one in the bottom.
Inconsistent tent. That was pretty good. Very special. Because this is saying x plus 10z equals 0. 1 y. I better fix that. Y minus 7z equals 0. And 0 equals 1. And 0 does not equal 1. It doesn't make sense. What's up?
Just that last problem, the z equals z, do you have to put that one still in the dependent, or do you put that one in the independent?
This one is dependent.
So all of them go in the dependent?
So let's go back to the test and I'll show you. It says the first row is independent. So that's x equals y equals z equals. Consistent and dependent. The second one is consistent and dependent. So the last one would be z equals z. And then in the third one, it's inconsistent, so you type yes, and all of the rest of them will be nots. Does that make sense? This one is partial fraction decomposition. This is the easiest example of the partial fraction decomposition. So I'm just going to factor that x plus 4, x plus 5. So if I were you, I would write somewhere a over x plus 4 plus b over x plus 5. Because a and b can be interchangeably used. So this equals a over x plus 4 plus b over x plus 5. And we need common denominators. So this needs x plus 5 over x plus 5. I don't want to write it. It's too much. And this would be x plus 4. If I write it shorthand, is that okay? Is it bugging you? Yeah, I didn't really write common denominators. I just added it to the numerator because I know I'm going to clear it. 6 equals a x plus 5 plus b x plus 4. And then we have the let x equal, and we'll go negative 5. So 6 equals, and if x is negative 5 here, it would be negative 5 plus 5 would be 0, and a times 0, it goes away, and that's by design, plus b negative 5 plus 4. So negative 6 equals negative b. So b equals 6. Oh, what did I do? Oh, I don't know why it went negative. I actually think I was thinking about what the answer is. No, I really was. It is b equals b. So b is 6. I'll fix it. B equals negative 6. So this is negative 6. And that's how I would do it. When you're writing it out on in your work, that's what I would do. I'm gonna make some more room. And then we're gonna let, what color should the other let be? We'll do brown. Let x equal negative 4. So 6 equals a negative 4 plus 5. Oh, this is so cheddar. So a is 6, yeah? So a is 6. And you put it in just like that. This one is the same problem number. This is still number 4, but this is considerably harder. This one's much harder. Don't factor the numerator, just factor the denominator. Even if it does. Does this one factor? 6 and 3? It does, doesn't it? So it would be x squared.
Still number 4, right?
Still, this is another version of number 4. Because of what the CBE does to you. There are easy and hard versions of the same problem. Like the first one, if you're worried about this at all, this is the one you want. This one's cheddar. This one's, I mean, it's not terrible, but not as cheddar. I'm going to GCF of x squared. So then a over x plus b over x squared plus c over x minus 3. And it's x and x squared because it is a repeated root. So you have to list it twice. So I'm going to rewrite all of that. Oh, I can do what you guys can't. So this guy here needs a x and a x minus 3. B over x squared, it just needs a x minus 3. And x minus 3 just needs a x squared. So the numerator is x squared minus 3x minus 18 equals a x minus 3 plus b x minus 3 plus c x squared. The first let x equals 0. And that's going to wipe out, it's going to wipe out this term, this term, this term, and this term. Is that clear? Luke said yes, so we're moving on. Negative 18 equals b, and this is 0 minus 3. So b equals 6. You mean to show it? This would be negative 3b
It's fine.
divided by negative 3. So b equals 6. So I'm going to go up here just to be organized and put in 6 for b. Then the other let, I'm going to cheat again. And let x equal 3. And that's going to get rid of this term and this term. So 3 squared minus 3 times 3 minus 18 equals c times 3 squared. So 9 minus is negative 18, is that right? Equals 9c, and c equals negative 2. So I'm going to go way up here and put negative 2 in for c. Am I going too fast, or are we okay, you guys? We all right? So I'm going to cheat again. And we're going to use what we found for B and C to find A, because there's nothing else we can use. There's no more zeros. It's actually excluded values. It's interesting that to find what the numerator is could be, we're going to use numbers that you can't have. So I'm going to write up here. What was B was 6 and C was negative 2. And then we're going to let x equal 1. 0 is the easiest. After 0, 1 is the easiest. So this is 1 minus 3. Oh, I got to change the color so it looks prettier. We've used orange. We'll go blue. It's the most interesting part of my day is picking which colors. 1 minus 3 minus 18 equals A times... Oh no, A is... Oh, we don't know A. Equals A 1 minus 3 plus B is 6. 1 minus 3 plus C is negative 2, 1 squared. 1 minus 3 minus 18, is that 20? Negative 20 equals 1 minus 3 is negative 2, negative 2a plus, no, minus 12 plus minus 2. How did I do? Feeling good about it. That doesn't mean I got it right. So negative 20 equals negative 2a minus 14. So add 14 and we get negative 6. So a equals 3. So way up here at the top, a equals 3. Oh, blue, I already used blue. Should have done green. See, now it's all a little too monochromatic. Wow, that's a lot of syllables for one word. That's 5 syllables. That's pretty good, huh? I'm impressive. Okay. This one is the long division one because the numerator is bigger than the denominator. So negative x to the fourth. Nope. X cubed plus 5x squared. Negative, yes. I think we practiced these quite a bit. You hate them? Wow. I don't feel like that's deserved. I don't think it's that bad. Yeah. Wow, that's a little aggressive, man. Negative x, yeah. And that will be negative x to the fourth minus 5x cubed. This is actually easier to do when you have lots of colors. 0 and negative 2x cubed minus 5x squared. And that's going to be minus 2. Oh, green isn't an option. Don't, well, it is, but like, it's not one of the ones on my palette. So then negative 2. Bless you. What was that? Aubrey can't sneeze?
It was like a weird.
I didn't think it was weird, Aubrey. She's not actually sorry. Negative 2x cubed minus 10x squared plus 12x. Change the sign. And 0, 5x squared minus 12x.
Wait, why'd you bring down
Oh.
Whoa, 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 whoa.
Plus 12x minus 15. Oh, it feels like Aubrey just sneezed again. That is the remainder, right? So this is plus 5x squared plus 12x minus 15 over So this is what I got from I don't want to rewrite all of that. Let's see if I can figure it out. Oh, wait. So this is what I got from the long division. So we have to do partial fraction decomposition with this part of it. So 5x squared plus 12x minus 15 over x squared x plus 5. We have another repeated root, so this is like the worst of all of them. Or the best, depending on how you look at it. A over x plus b over x squared plus, whoa. I always think it's kind of cool actually when that happens because it's like a lightning bolt. I don't know how it happens. If I could make it happen again, I would. 5x squared plus 12x minus 15 equals. And I'm just going to bring that down actually. So this needs an x and an x plus 5. This needs an x plus 5, and this needs an x squared. It's going to take 45 minutes to do this one problem.
No, you have to give us both.
5x squared plus 12x equals ax x plus 5 plus bx. Oh, no, plus 5. I don't think I could do this if I didn't have my little scoop button. Plus cx squared. We'll start with brown. Let x equals 0 and negative 15 equals 5b. So b equals negative 3. So I can go up here to the sacred version and erase b and put, what was it, 3? Negative 3? Negative 3. Oh, the next left. We've used orange and pink. We'll do purple. Let x equal negative 5. Look at that. negative 5 squared plus 12, negative 5. I gotta write smaller. Oh no, I don't. Because that is plus c negative 5. Good. Feeling 125 over here. Negative, no positive. Minus 60 minus 15 equals 25c. Did I do that right? 125 minus 60, is that 65? Is it 50? 50 equals 25c. Look how handy that is. C equals 2. So up here, C equals 2. And now we got to find A. Well, this is taking pages and pages. See, I know what I get what you're whining about before. It's not letting me add a page. What is going on? Figured it out. Thank you. So we're going to let x equal 1. So 5 plus 12 minus 15 equals, and A we don't know. A times 1 plus 5 plus, what's B? You guys are not B.
We know A.
We don't know A.
We don't know A, I lied.
We don't, what was C?
Jokes.
C is 2. How come it went away? B is negative 3, is that right? Plus, and then what was C? Plus 2. 2 times 1 squared. So 5 plus 12, so is that 22? No, it's 2. 10, negative 10 is 2, right? 2 equals 6a. Yeah, 6a. And then 5 minus 3 is 2. Plus 2. Oh, yeah. Yeah, I just subtracted. I don't know what I did. None of that's making sense. Negative 3 times 6, so that's negative 18. That's 2 equals 6a minus 16. So 18. So a is 3. A is up here at the beginning. A is 3. So now I need all of this. So it's actually just like this. Negative x minus 2 plus that's the answer. Because I just did all of that work to replace this part. What's that? Because the question says, write this in partial fraction decomposition. So we just decomposed that negative x to the 4th. If you did all of the addition, you would get back to this pink guy up here. If you undid everything and got common denominators with this, it would turn into that. Hopefully, if you did it right. I feel like the test gets considerably easier now. There are some of these ones that can get tricky. I tried to find the ones that are tricky. Some of them are tough. You can substitute any way you want, but this x squared right here makes me want to substitute for y here. So I'm going to take the first equation, negative 2y plus 28x equals 38. So there's not like a right or wrong easy version. What if I divided everything by negative 2? Y equals y minus 14x equals 16, 19, negative 19. Is that right? And so I'm going to add 14x to both sides. So y equals 14x minus 19. And I'm going to take that and plug it in here into the other equation for y. So it's negative. Negative is important. Negative 14x minus 19 plus 2x squared plus 2x minus 1. Wait. When I converted it, it lost the equal sign down there at the bottom. I'm guessing it's got to be this one right here. Equals 1. Oh, we could. Yeah, we might never know. Negative 14x plus 19 plus 2x squared plus 2x. 1. I'm going to make it equal 0 because it's a quadratic. So 2x minus 12x plus 18. Did I do that right? Oh yeah, 12 squared, thank you. I'm going to divide by 2 again. So x squared minus 6x plus 9 equals 0. And I think that's x minus 3 squared. So x equals 3. No. Are we okay so far? So I'm going to go back up here and negative 2y plus 28 times 3 equals, oh, what in the world? 38. I don't know what 28 times 3 is. 25 times 3 is 75. 61? No. 75.
That was close.
Plus 9. 84. 25 times 3 is 75. So, oh, you'd have to add 15 more. 9 more? 54? Okay. 2y. Okay, I'm just gonna. 84. So minus 84. Negative 2y equals 38 minus 84. Negative 46. And y equals 23. So the answer is 323. Feels like we should have 2 solutions. Because graphically, we have a parabola and a line.
But we have, isn't that just to the
So we have a parabola.
it was x squared, it was x minus this squared.
And a line. Feels like it could be a tangent line. Yeah, we got the, yeah. I'm just worried about the solution. I don't think we did though. So this is a circle and a line What's up? Yeah, this is another version of the same one, just still number 6. This is another, this one is a circle and a line. Could have one solution, could have 2 solutions, could have none solutions. I don't really see an easy way. I'm going to just add 3x to both sides. So y equals 3x plus 7. And that would go in for y in the first equation. Negative x squared minus 3x plus 7 squared plus... Oh, wait a minute. Never mind. Because this other equation has 2 y's, I'm going to start over again. I'm sorry. It would be fine, it just isn't the easiest way. It would have been fine. Do you want to undo it and keep going?
What? No, let's just start.
Or you erased it, Kobe.
I unerased it.
I thought you were ready.
No,
No, it's not, look.
You should re-erase it.
re-erase it.
Because if we do it the other way, we're going to end up with a fraction.
Well,
So you have to weigh.
fractions are better than having to rewrite the whole thing.
Actually?
No, but.
Because we're gonna have. Yeah, it's kind of a gnarly fraction, actually.
So we're rolling with this one.
I think we're rolling with this one. Plus 6.
I hate rewriting.
It's not hard for me. I just have to tap.
I'll be in that.
6. Thank you. 3x plus 7 equals 1. We're gonna end up with fractions anyway.
Oh my gosh, Kobe.
This is 9x squared. 2142x. Did I do that right? 21 twice 42? Feels right. Nobody's gonna check me.
Sounds good.
You probably shouldn't. Plus 18x plus 42 minus 1 equals 0. That's right, 6 times 7 is 42. 9x squared, that's negative 10x squared. 42 and negative 42 and 18. What is that? Negative 26? Negative 24. X. And negative 49 and 42, that makes 7. 7 minus, negative 7 minus 1, negative 10. Is that right? Negative 8. And because it equals 0, I can do this. I'm glad you like it, Luke. Plus 12x. Plus 4. Yeah, I took out the negative because I don't want the leading term to be negative. Because I think it's easier. And that's going to be 20 and 12. Is that going to factor? You think so? 5x and x, 4 and 1. 5x, 4x, that's 9x, that doesn't work.
Or 10 and 2.
10 and 2? Ah, gotta do X games. 20 and 12, 10 and 2, 5x, x, so 5x plus 2. And x plus 5. Right? Oh, plus 2, plus 2, plus 2. So x equals -2 and x equals -2/5. No. So now we got to go up here. So we can plug it into either one. I think the bottom one looks like an easier option. -3, -2 plus y equals 7. That's 6 plus y equals 7, so y equals 1. So here, this version, -2, 1. Yeah? That's okay? Then the next one, I'm out of room. -3, -2 over 5 plus y equals 7. So that would be +6/5. So -6 over 5. This would be y equals 35 over 5 minus 6 over 5. 29/5. That's horrible.
Yeah, we should have just done it the other way.
Well, I mean, it would have given you the same answer. X. What do we decide? 29 over 5? These are the two answers. Oh yeah, we only got to number 7. So you guys, the way I want to do, are we out of time?
Yeah.
I will stop the recording.